Welcome to solverfy.
Okay, so we're doing chapter 23, problem 39 here. So we have a rod of length 2L, which is centered on the x-axis, and it carries a uniformly distributed charge Q. And we want to determine what V of x is for points along the x-axis outside of the rod, so out here. So if we take this as our point, we want to figure out what dq is going to be, because we know that we can write the potential as 1 over 4 pi epsilon naught the integral of dq over r. Okay. So if we choose a differential element of the rod here that we call dq, this is at a position x prime away from the origin, where the width of this rod is given as dx prime, the width of that little section, dq. So now if we have dq is dx prime times the surface charge density, or the linear charge density. And the linear charge density is just the total charge over the total length of the rod. Let me write that better. Okay, so this is times dx prime. So now we know what dq is. So let's write the potential as 1 over 4 pi epsilon naught, the integral, and now we have q over 2l dx prime. And this, right here is our r. So if you see, if we're at a point of x, then our r is x minus x prime. So let's go ahead and write that. So this is x minus x prime. And now, where do we need to integrate from? Well, we need to integrate over the whole charge distribution, and that starts at negative L and goes to L in the x-axis. Cool. Now that we have all this, let's just simplify things. So we have Q over 8 pi epsilon naught L, the integral from negative L to L, and we have dx prime over x minus x prime. Cool. And we can just easily integrate this, and this becomes q over 8 pi epsilon naught L, and then we have negative ln of x minus x prime, all evaluated at negative L to L. So let's evaluate that at those points, and we get q over 8 pi epsilon naught L times natural log of x plus L over x minus L. Awesome. This is V of x.